What's up? Let's get connected with our connective tissue. You know what I'm saying? All right, so connective tissue. Connective tissue. Let's go through our examples here. We'll start with kind of like what you think of actually when you hear the word connective tissue, which is like fibrous connective tissue. All right, so connective tissue, fibrous connective tissue. And let's just kind of draw out fibrous, fibrous connective tissue. And there's different types of this, but we're just going to kind of draw a general one here. So let's say we got our old, I'm sure we've heard this word, got our collagen fibers, which are actually made out of a bunch of tiny fibers. And these are protein. And like 1/3 of all your protein in your body or something is collagen, which is kind of crazy because you think about your muscles, but I think that's about something what it is. It's a lot of your protein goes to making collagen. So we got, like, let's say a collagen fiber, and these provide like major support for your body. Like they hold your body together. It's a bunch of proteins wrapped together. There's different types of collagens. And then we have, let's say, associated with this and crawling through here, we got something called a fibroblast, which is a type of cell that helps deposit collagen and other fibers. We got a fibroblast. And these guys are real crawly cells. Crawly cells that deposit fibers. Boom. So if you get a cut on your skin, you're going to have a bunch of fibroblasts crawl to that cut, start to deposit fibers to help fill in that cut, and that forms eventually like a big, dense, granular tissue of fibers, and that is a scar. Let's say over here we've got ourselves a little, and we're going to maybe draw some of these out too. We got ourselves a little kind of big roundish looking cell like that. Maybe we got two of these guys like so, and they would of course have their nuclei, maybe something like that and like that. Oh, they're kind of cute. These would be fat cells. And then let's say we've got a fiber, another fiber, let's say, it'll look something like this. That might actually look okay. Yeah, that actually looks all right. It kind of help hold the tissue together. Actually, I don't like that. I'm drawing them kind of squiggly like this because these are your elastic fibers, or your elastin fibers. We have elastin fibers, or elastic fibers. And these help basically prevent shape change, or help return the tissue to its original shape. So elastin is the protein name. The fiber itself is called elastic. So, and these help maintain tissue shape. This is one of the reasons collagen breaking down and elastin breaking down when we age, why we get wrinkles and our skin sags, is because we're not able to replace these proteins in the same way that we were able to. They start to break down. And then everything gets a little saggy and a little wrinkly because we don't have a nice tight, large amount of elastic fibers to keep everything nice and plump, let's say. These are really important, like around our bladder, for example. our bladder is going to stretch way up, and then we're going to want to shrink that boy back down with our elastic fibers. We also have other little fibers called reticular fibers. These are important in wound healing. So we have reticular fibers. Those are our 3 fiber types. And then we'll have something maybe like this guy over here. Out here in this connective tissue, we'll have a white blood cell. So we'll have a white blood cell. It's not in the blood. White blood cell, which is an immune cell. So he's out there looking for bacteria and things. And we can have different types of them out there. And yeah, that's kind of a basic little overview of a connective tissue. So we have, more sparsely spread out cells, and then we have a lot of fibers in the extracellular matrix. So this would be an example of loose connective tissue, let's say. This would be loose connective tissue. There's also another type. There's a couple different types, but the one I'm going to talk about is dense connective tissue. And so this would be like this would line our organs. This would line our organs. Whereas dense connective tissue, this is like our tendons and ligaments. Dense connective tissue is a lot of fibers. So it's just going to be a ton of, I'm going to kind of draw it zoomed out, just collagen fibers. Obviously, you look at a tendon, it's just like a bunch of fibers. So these would be all the collagen fibers. And it actually looks kind of like this. It's very wavy. I'll pull up a picture in a second of each of these. Like this, and then we would have our little fibroblasts kind of decorated in here, hanging out with the little bacon. We got a little fibroblast hanging out with our little bacon. And we'd have some nuclei on those as well. So we would have fibroblasts helping to deposit the collagen, fibroblasts. And then we would have our collagen fibers. Okay, pretty cool. All right, let's pull up some pictures of these. Oops. So we got our loose connective tissue here. Looks something like that. Pretty nifty looking. Let's see if I got a dense connective tissue. I do. Give me 1 second. Okay. So that's our loose. We can see our collagen fibers, our reticular and elastic fibers here in purple, and all of the nuclei of our little cells. And I can't tell if these are fibroblasts. This maybe looks like a white blood cell. And then these are probably all fibroblasts. I don't see any fat cells there, but they could also be there. All right, so here we've got our dense fibrous connective tissue. And you can see they look like that. Like these are collagen fibers, and then these darker spots are fibroblasts. Pretty nifty, and it looks wavy like that, like bacon. Pretty cool stuff. All right, now let's just keep cruising. I'm not going to spend too much time more there. Next up is kind of cartilage, and cartilage has a very specific kind of structure to it. So they've got like a dense, so this is fibrous connective tissue here. I'm going to have to adjust, I'll put it down there. Fibrous connective tissue. Now let's put cartilage. Cartilage. And they look kind of like this. Like there's just a density of fibers. They're almost like in like a 3D like kind of matrix. Something like this. And this is actually what bone gets deposited on, is this matrix. So it's like a matrix of fibers, so super dense that you can't even really see anything. It's called ground substance. It's made out of collagen fibers, polysaccharides, as well as other things. Matrix of fibers, it's called ground substance, made out of collagen and polysaccharides, as well as other things. So it's a mixture of protein and sugar, right? That's what that is. And all kind of decorated through here, we have little specialized cartilage cells. This is going to look like cheese if I do them as perfect little circles. They do look pretty circularly, but they don't quite form perfect little circles. And it does actually kind of look like this. It's pretty cool. And these guys hang out like that. So these would be little chondrocytes. That's what they're called. Chondrocytes. Got that right? Chondrocytes. Boom. And this is a specific type of cartilage called hyaline cartilage. Hyaline cartilage. And this forms basically at the ends of your bones. Hyaline cartilage at the ends of your bones. So like it provides a cushion. And it also lines your trachea. To keep your windpipe open. To keep it open so it doesn't collapse. So you have little cartilage discs in there to keep it open. And let me pull up some pictures of this. So if we take a trachea and we actually open it up, like, because it's a tube wrapped up like this, we open it up and flatten it out. This is what it would look like. And we're going to actually look at tracheas in lab on rats. You'll be able to see this. So each one of these discs here, so this is again, it's kind of opened up like this, so it would wrap up like that. Each one of these discs is a hyaline cartilage. So it's a bunch of collagen fibers with little cells living inside of it called chondrocytes depositing these fibers. And if we actually take an electron image of this, electron micrograph image, this is what it would look like. So this is the ground substance all here. You can see how it looks like these little fibers and things. And then these are the little chondrocytes, and they live in these little divots called lacuna, just like in bone. We saw those in lab. Pretty nifty stuff. So that's cartilage. I already talked about blood, so I'm not going to redraw that one out, because we're also going to go into blood into more detail. But blood is a connective tissue. And we're also going to talk about bone in the future. I'll list it out here because I just want to show a couple pictures. So bone is also a connective tissue. I just want to show a couple pictures of it. We're going to go into all the details of bone here in the next week's lectures. But similar to these chondrocytes living in these little lacuna, here we have an osteocyte, or a bone cell, living in its little lacuna. It's really cool. And they have these little tendrils that come out. So this is a bone cell. You guys have drawn a picture of this before, most of you. It's a bone cell. And it's also called an osteocyte. Beautiful. And they've got these little tentacles that come out into things called canaliculi. and they live inside of these little holes called lacuna. And this stuff is all made out of, right? It's an extracellular matrix, not made out of fibers. This, once upon a time, was this ground substance, and then bone cells came in, and they deposited this substance, which is called calcium phosphate. It's calcium phosphate crystal to harden cartilage into bone. Okay, one last I'll just say calcium crystal, that's fine. It's got phosphates in there though too. One last connective tissue that I want to talk about is adipose tissue. We don't really think of this one usually, adipose tissue, which is our fat. This is our fat. And I drew these cells out a little bit earlier, but they look like something like this. They're really kind of big, droplet, globule looking guys, like so. And their nuclei are all pushed off, usually to the side, to one of the sides. So if we draw the nuclei in, it'll look something like this. And they look kind of cute. So adipose tissue, fat tissue, and this is, obviously for energy storage and insulation and protection. And it is also a connective tissue. And I should have a couple pictures here that I want to show. Fat. Yeah, let me just, oops. I do have a couple pictures here. So here's adipose tissue. This is what it looks like under the microscope here. Beautiful. So you can see how these nuclei are all pushed to the side, and this whole kind of center of the cell is just full of triglycerides. So energy storage. And this would be a blood vessel here. This would be the nuclei. This would be like an outer layer, probably an epithelial layer of kind of the edge of the connective tissue. It's pretty beautiful. And I wanted to show another image of this, what this looks like under the light microscope. Looks something like this. Why does it not let me? Well, it's going to have bone with it. It's okay though. Okay. Let's put it right here in between them. They're opposite, but this is what hyaline cartilage would look like under a light microscope. So these would be those chondrocytes, and this would be that polysaccharide collagen fiber matrix. These are the bone osteons, which we've looked at and we'll talk about more in the next lecture here. And last but not least, there was one last thing I wanted to show you, which was this, which is this fibrous connective tissue under an electron micrograph. It's pretty cool. So this is this dense fibrous connective tissue, so our tendons and ligaments under an electron micrograph. And you can just see how beautiful these collagen fibers are. And just how many, there's a cool bird out here, sorry. Just how many little fibers make up these big fibers. Okay, that's it on connective tissue. Pretty cool stuff. It's pretty crazy to me that blood is a connective tissue. You can blow some people's minds with that fact. Like, what kind of tissue is your blood? And people will be like, I don't know, man. I don't even know. I don't even know where the Pacific Ocean is, even though I live on the West Coast in California, brother. I don't even know. What kind of tissue is blood? Is it meat? And he'll be like, no, it's connective tissue, you freaking idiot. Why don't you learn some facts and get off TikTok, homie? What are you doing with your life?